Students, having known that matter is made up of atoms, the next immediate interest of the scientist was to determine the masses of the atom. So let us begin with today's discussion on the topic atomic and molecular masses, equivalent masses, and mole concept. So let us begin. As, however, as an atom is so small a particle that it cannot be seen or isolated. Therefore, it is impossible to determine the actual mass of a single atom by weighing it. Alternatively, the mass of an atom could have been calculated by weighing a large sample of the element and then dividing by the number of atoms contained in it. But unfortunately, there was no method known to count the number of atoms. So the problem was finally solved. In the beginning, the atomic masses of all the elements were obtained by comparing with the mass of hydrogen, taken as 1 because it was the lightest element. But by doing so, the atomic masses of most of the elements came out to be fractional. Hence, the reference was changed to oxygen, taken as 16. However, a still better reference, which is now widely accepted, has been found to be carbon, taken as 12. On this basis, the relative mass of hydrogen comes out to 1.008 and that of oxygen as 15.9994, or we can write it as 16. Hence, atomic mass of an atom may be defined as like the atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon, taken as 12. So, the masses on the atomic scale are expressed in terms of atomic mass unit, that is AMU. And now it is been in place of AMU, we can write it as U, that is unified mass. So AMU, one atomic mass unit, is equal to 1 by 12th part of the mass of an atom of carbon 12 isotope. So thus the atomic mass of hydrogen is 1.008 U, while that of oxygen is 15.9994 U or 16 U. So we can define atomic mass of an element is the average relative mass of its atoms as compared with an atom of carbon 12 taken as 12. So there are various atomic masses. You must be knowing the atomic masses of aluminium 27U, boron 11U, calcium 40U, chlorine 35.5U, and so on. So now in terms of percentages of the different isotopes, the average atomic mass can be calculated by the following given formula. A bar will be equals to summation of Pi Ai divided by 100, where Pi is the percent abundance of isotope with atomic mass Ai. In your previous class, in class 9, you must have done this topic average atomic mass, and you have calculated, used this formula for calculating the average atomic mass. Like suppose chlorine, which occurs in nature in two isotopic form with masses 35U and 37U. Suppose they are occurring in the ratio 3:1, means one isotopic form is occurring in 75% and another one is 25%. So according, by using this formula, we can calculate the average atomic mass of chlorine will be equals to 35 into 75 by 100 plus 37 into 25 by 100, isn't it? By using the given formula. So ultimately we are getting 35.5 U, which is the average atomic mass of chlorine. Or there is one another method for calculating it. The average relative atomic mass of an element can be calculated from the fractional abundances of the isotopes of that element. Now, fractional abundance. Fractional abundance of an isotope is the fraction of the total number of atoms that is comprised of that particular isotope. For example, you can see over here, average atomic mass is the sum of the products of fractional abundances, that is Fi, of the isotopes and their corresponding mass numbers, that is Ai. So ultimately we can write formula A bar is equals to summation of Fi Ai. That will be equals to, we can write in expansion form, F1A1 plus F2A2 and so on. Let us take one example. Suppose naturally occurring neon consists of 3 isotopes, the mass numbers of which and their fractional abundances are as follows. You can see over here from the chart given, the 20 neon means mass number given 20, 21 and 22 neon isotopic forms, and their fractional abundances are given. So what will be the average atomic mass of neon? That will be equals to 20, the first mass, into fractional abundance, plus 21 into the fractional abundance, 22 into fractional abundance, using the given formula. So ultimately we are getting 20.179 U. That will be the average atomic mass of neon. So there are some more terms in masses. So these are like the atomic mass of an element expressed in grams is called gram atomic mass. Suppose example given, atomic mass of oxygen is 16 U. So when we have been asked to write down gram atomic mass of oxygen, then it will be 16 gram in terms of gram. Next one is the molecular mass of a substance. The molecular mass of a substance is the average relative mass of its molecules as compared with an atom of carbon 12 isotope taken as 12. So, and one more term is gram molecular mass. The molecular mass of a substance expressed in grams now. So that would be the gram molecular mass. Here we have taken example of HCl. So molecular mass of HCl is H1U plus Cl 35.5 U. That would give you 36.5 U. So when we have to write gram molecular mass of HCl, that would be equals to 36.5 grams. So this is all about atomic and molecular masses. So moving further, there is one more important term, that is equivalent mass. So the equivalent mass of a substance is defined as the number of parts by mass of that substance which combine with or displace directly or indirectly 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. So let us understand it by using some examples. So calculation of equivalent mass. So first formula for calculation is equivalent mass of an element will be equals to atomic mass of the element upon valency of the element. For example, we have taken the equivalent mass of copper in CuO. So copper having atomic mass 63.5 U divided by the valency of copper in CuO is 2. So 63.5 divided by 2, that will give you 31.8. That will be the equivalent mass of copper in CuO. If we are changing the formula Cu2O, so equivalent mass of copper will be equals to atomic mass is fixed of copper. So that is 63.5 divided by valency. So valency of copper in Cu2O is 1. So ultimately we are getting equivalent mass 63.5. The next formula is, suppose we have to find out the equivalent mass of an ion. So suppose we have to find out equivalent mass of carbonate ion, CO3 2 minus. So for finding it out, what we have to do, we have to find out the mass of the ion, formula mass of the ion, that is CO3 means 12 plus 3 into 16 divided by charge on the ion, carbonate ion having charge 2 minus, so 2 will be the charge. So ultimately we are getting 60 upon 2, that is 30 is the equivalent mass of carbonate ion. So similarly there are some more formulas for finding out the equivalent mass, like equivalent mass of an oxidizing or reducing agent can be calculated by the given formula, molecular mass upon number of electrons lost or gained by one molecule. Next one is equivalent mass. Suppose we have to calculate equivalent mass of an acid, then that is calculated by molecular mass of the acid divided by basicity of the acid. Now what is the meaning of the term basicity? So basicity is the number of displaceable H plus ions present in one molecule of the acid. Next one, equivalent mass of a base. What is that? It can be calculated by molecular mass of the base divided by acidity of the base. So what is acidity? Is the number of displaceable OH minus ions present in one molecule of the base. So these are some of the formulas through which we can calculate equivalent mass. So this term, this equivalent mass, we will discuss later on under the topic normality. So let us proceed further. Now moving towards our next topic, that is mole concept. So we have discussed till now how the relative atomic masses of the elements could be determined. But the problem of finding the absolute masses of the atoms remained unsolved until it became possible to count the number of atoms or molecules in a definite amount of the substance. It is found that 1 gram atom of any element contains the same number of atoms, and 1 gram molecule of any substance contains the same number of molecules. So this number has been experimentally determined. What is that number? That number is equals to 6.022 into 10 to the power 23. So that number is called Avogadro's number or Avogadro's constant in honor of a great scientist, Amedeo Avogadro, a great pioneer in this field. So we can represent this number by n subscript a. So Avogadro number is defined as the number of atoms present in 1 gram atom of the element or the number of molecules present in 1 gram molecule of the substance. So now the amount of substance containing Avogadro's number of atoms or molecules is called a mole. So mole is a chemist unit of counting particles such as atoms, molecules, ions, etc., which represent a value will be equals to Avogadro number, that is 6.022 into 10 to the power 23. So when we are saying that 1 mole of hydrogen, so it is wrong to speak 1 mole of hydrogen. We must specify whether we are referring to hydrogen atom or hydrogen molecule. So thus we can define mole in terms of mass, in terms of number, in terms of volume. So these are the some of a few lines, few definitions of mole in terms of mass, number and volume. And the standard definition is SI definition of mole. That is, a mole is that amount of substance which contains as many elementary entities as there are atoms in exactly 0.012 kg, that is 12 gram of carbon 12 isotope. The elementary entities must be specified, that is whether they are atoms, molecules, ions, electrons or any other entity. So this is the standard definition of mole. So the mass of 1 mole of any substance is usually called its molar mass. So we can calculate the number of moles will be equals to given mass by molar mass. This you must have read in your class 9 for calculation of number of moles. So this is this mole calculation. Let us do something. Calculation on mole concept. That is, first question is, in 3 moles of ethane, that is C2H6, it is a hydrocarbon. You all of you must be knowing. Calculate the number of moles of carbon atoms, the number of moles of hydrogen atoms, and the number of molecules of ethane. So first one is, in 3 moles of ethane been given to you. You have to calculate the number of moles of carbon atoms. So you are knowing 1 mole of ethane is containing 2 moles of carbon atom. You can see from the formula itself, 2 moles of carbon atoms. So that therefore we can write 3 moles of ethane will contain how many carbon atoms? That will give you 3 into 2, that is 6 moles of carbon atoms. So for the calculation of number of moles of hydrogen atom, we can see from the formula 1 mole of ethane is containing 6 moles of hydrogen atom. So 3 moles of ethane will contain 18 moles, that is 3 into 6, that is 18 moles of hydrogen atom. So third one is number of molecules of ethane. So how we are able to calculate the number of molecules of ethane? So we are knowing in 1 mole of ethane, it contains how many molecules? It contains 6.022 into 10 to the power 23 molecules. Here there is a discussion about molecules. That's why we have written 6.022 into 10 to the power 23 molecules. So we have to calculate the number of molecules in 3 moles of ethane. So therefore 3 moles of ethane will contain 3 into 6.022 into 10 to the power 23 molecules, that is equals to 18.06 into 10 to the power 23 molecules. So let us discuss one more question. The question is like this: which of the following will have largest number of atoms? So options are being given to you. First see the question, then try to answer by your own. 1 gram of gold, 1 gram of sodium, 1 gram of lithium, 1 gram of chlorine molecule. So the atomic mass is being given to you. You have to tell which one of the following will have the largest number of atoms. Means you have to find out the Avogadro number of atoms. So the answer is third one, 1 gram of lithium. Because you can see over here, for calculating the number of atoms, we have to go for the formula, that is given mass by molar mass. So given mass is 1 and molar mass is 7 for lithium. Again given mass for gold is 1 and molar mass is 197. Similarly like that. So when we started comparing the denominator of all the lithium, gold, sodium, chlorine, then we are able to see that it is highest for gold and it is the lowest for lithium. So that's why we are getting more number of moles in 1 gram of lithium. So when we are multiplying the number of moles into Avogadro number, then we are getting the largest number of atoms in 1 gram of lithium. I hope you have understood. So try to solve more questions on mole concept topics. There are many questions given in your NCERT textbook. So refer to it. So to discussed about atomic and molecular masses and mole concept. Thank you, students.